Now we turn to a fundamental concept of engineering economics, that is time value of money. It sounds a little bit strange. Time value of money. Why does money has anything to do with time? And how does time add value to money? In fact, if we think of it, it's not that difficult to understand. Just imagine that you have a certain amount of money. If you put the money in the bank with the interest, then over time you will accumulate the interest. So the same amount of money, not using it for any kind of investment, the value increase automatically. So even if you don't use the money for investment, just put it in the bank, just the interest alone will change the value of the money. And basically, the value of the money can measure by the interest rate, meaning that if we consider a different interest rate, the value of money over time will change accordingly. An interest rate of 1% versus an interest rate of 2% will reflect on the time value of the money. So the money will have different value over time based on different interest rate. On the other hand, if you think of yourself borrowing money rather than depositing your money in the bank, you probably also understand that there must be a cost. You borrow the money, you need to pay for the money you borrow over time. The longer you borrow the money, the higher the interest that you need to pay. So we can also consider interest as the cost to the borrower. Okay, so we borrow the money, and even if we do not do anything, over time the money that we owe will be increased. So all these reflect that there's a very tangible, realistic value change on the money that we hold over time. So with this kind of situation, right, if we are given different alternatives, these alternatives involve a number of money or cash flow in and out, and it's very difficult to compare two sets of cash flows because they just occurred at different time. It's you cannot just add them together and compare, and you cannot compare just at different time, then sum them together and compare. So instead, what we need to do is we need to convert these occurrences of the cash flow, inbound or outbound. We need to convert them into a specific time point, whereas the other cash flow, we also need to convert all of them to the same time point so that we can compare them. When they are at the same time, we can compare them directly. When they are at different time, because of time value, the difference of time value of the money, we cannot compare them directly. So we need to be able to convert. However diverse the cash flow is, we need to convert them into a value at a specific time point. And if we want to make comparison, we need to compare the other set of the cash flow into a single value at the same time point too. Then we can do comparison. That require a little bit of course we can say we have 1,000 such kind of cash flow, we can do one by one, convert them somehow, some way to the specific time point. But yeah, a lot of cases where we can have a much simpler formula to convert a very long series of cash flow into a single value. So this is something that we are going to discuss. That is how to treat these cash flows and based on the time value of the money, convert them into the same standpoint so that we can compare them, convert them into the to the same standpoint so that we can compare them. So here will be an example so that you know what is going on. Supposedly you borrow a certain amount of money, let's just say 20,000 US dollars, and you need to pay it back in different plans. And again, as I said, the time value of money is related to the interest rate. Once you set the interest rate, you should be able to use the interest rate to compute or to convert certain value into another series of cash flow. So you receive certain amount of the money, 20,000 US dollars, at the interest rate 9%, and you need to pay back this amount, and your payback will be considering, or whatever series that you have need to be equivalent to the value that you borrow at this point. Okay, so if that is so-called year 0, that is right now, and plan 1, you will be deducted $200 direct on the money. Okay, and similarly plan 2, you do that. For plan 1, you pay back the rest of the amount in 5 equal installments. So it has been calculated that 5,141.85, that is the amount that you need to pay, so that if you convert them into the present time at the interest rate of 9%, the value of this time series is equivalent to 20,000 at the current time. Okay, but you add them together, you found out that the total value is bigger than 20,000. That is understandable because you need to pay for the interest, right? You need to pay for the interest. Similarly, for plan 2, you were deducted $200, so you didn't get that amount. For the rest of money, you will only pay all of them back. For the rest of them, all of them back at the end of year 5. Okay, at that point, you can imagine that the value will be a lot bigger because you did not pay anything back to the lender, and the amount that you owe will continue to accumulate interest until the end. You need to return all of them back in one lump sum payment back to the lender, so the value will be bigger. But in any case, we'll come back to this. We'll show how to do the calculation, just to show you that you receive 20,000, and in the end you are paying more than 30,000 at the end of year 5, and in fact you have been deducted 200 right from the beginning, but you are still paying more than 30,000. Is it reasonable? Okay, I guess there's whether or not it's reasonable, it depends, but this is based on 9% of the interest rate. The result is based on 9% of interest rate. So basically, if we use 9% of interest rate as the basis for consider time value of the money, then paying back at the end of year 5 for more than $30,000 plus not getting 200 right from the beginning together is equivalent to the value that you received at the present time, the value which is $20,000. Okay, so you borrow the money, and there are many ways. These are just 2 examples, plan 1, plan 2. There could be, as many payment plan you want. Right? It's just that all of them, based on the interest rate 9%, should come back to tell you that their values are equivalent to the value of 20,000 at the present time. So one thing that I also want to remind you is in engineering economy, when we are looking at a table like this, you see there's year 0. There could be year 0 until year 20, right? So year 0 means the present time. Year 1 means the end of the first year. So when people say year 2, you say, which point in year 2? Is it beginning or the end of year 2? In engineering economy, for tables or for diagrams, we always, when we say the first period, it means that the end of the first period. When we say 5th period, again, it means that the end of the 5th period. So we use end of period cash flow, unless we mention that it's the present time, so that we know precisely where we are. Because from the present time to the end of year 1 is already 1 year. There's 1 year gap. So whether or not it's in the beginning or is in the end, we sort of shift the entire cash flow by 1 year. So remember that we are using end of period methods, okay, or the representation of the cash flow. When we said year 2, it means the end of the 2nd year. If you look at it from the cash flow diagram, I think it's probably easier to understand. So in order to have a bit better visualization of the cash flow, we usually draw this so-called cash flow diagram. When it's going up, it means that incoming cash flow. When it's going down, it means outgoing cash flow, meaning that you are paying the money out. When it's going up, it means that you are receiving certain amount of money. Okay, so for the previous case, the case in the previous page, you receive $20,000, but 200 were deducted right away. So you only receive 19,800. That is the net cash flow at that point, at the present time. Okay, so you calculate the net, then you see whether or not it's you are receiving or you are paying. Receiving going up, paying going down. Okay, so that's at year 0. Year 1 will be at the end of the first year. So this is where it happens. After you receive the amount for 1 year, you pay this amount out, 5,141.85. Okay, and you pay this 5 installment. So that's how it works. And then you can see this is what I meant, that you receive 20,000, you were deducted for 200. So your net cash flow at time 0 will be 19,800. Okay, so basically this is how we do it. If you use the table, you are not sure where you are. You are not sure how many steps that you can move the value to time 0. You can always draw cash flow diagram. Sometimes people get confused and not very certain. They say, okay, at the end of the 4th period, how far away it is from time 0. Then you can just count 1, 2, 3, 4. I mean, 4 and 0 is quite obvious. But if I ask you, how far away is 5 to 1? Okay, sometimes 5 to 1, 5 minus 1 is 4. But if you are not sure, sometimes people get confused. 1? 1 is at the beginning. But anyway, here is very clear that 1 is here. So 5 minus 1, 1, 2, 3, 4. You know that you need to, if you want to compare everything at year 1, for 5, you need to move it forward to 1. Forward or backward. But anyway, move it to year 1. 4, similarly, you will move it to year 1. Then you are okay. Okay, you are moving them properly to the right place. Again, this is just to show you that how we record all these data, how we draw these data on a diagram so that we can easily visualize what is going on and try to find a way to solve the problem. And the interest rate, although we said that interest rate capture the essence of the time value of money. However, there are different ways of computing interest based on the interest rate. One method is called simple interest. The other is called compound interest. Simple interest meaning that every time you use the same principle, that is the amount of money you borrow, you always use that amount to calculate the interest that you need to pay over time. Compound interest is a little bit different. Compound interest means that you have borrowed a certain amount of money, but you did not return the money, any amount of money. So the interest that you owed will become the principal as well. So you will have a bigger principal, and will be charged for the interest based on the bigger principal. So as time goes by, your principal becomes bigger and bigger. So the interest rate is still the same, but the interest you are paying will be based on a bigger principal and thus a much bigger interest you will be paying over time. We used a very simple example to illustrate that. If you are borrowing, if you are depositing money in the bank, so you deposit 1,000, interest rate will be 8% per year. If you want to put it in the bank for 3 years. So if we consider simple interest, and every year, you see, every year you get 80 these are interest earned, because all the interests are calculated based on the principal, the amount of money you deposit. So if you look at your balance after 3 years, you look at your balance, it will be 1,000 plus 3 times 8, 80, 240. So it's 1,240. That is the total amount. That is the balance you will see at the end of the 3 years. If you are, or the bank is adopting compound interest, so again, you deposit 1,000, and at the end of the first year, because you have 1,000, so you get interest of 80, because the interest rate is 8%. However, there's a difference. Now your principal, meaning that the money you deposit in the bank, will now be considered 1080. So use 1080 multiplied by 8%, you get 86.4. That will be the interest that you earn. So you are moving this principal higher and higher. So you can tell that at the end of the year you get 80, then 86.4, then the third year, at the end of the third year, you get even higher, 93.31. So you add all of them together, it comes out to a value which is bigger than 1240. Okay, so compound interest, if you are adopting, or whoever lending you money is adopting compound interest, then the total interest that you earn or you pay will be higher than the total interest you earn or pay with simple interest. We can put them together, and again the difference will be as we have seen in two previous slides. One will be 1240 after 3 years. One will be 1259.71, which is a little bit bigger than the one with simple interest. That is the difference of simple and compound. And in fact, using compound interest, the interest will get bigger and bigger as the principal gets bigger and bigger. So we cannot ignore the effect of the compound interest. For simple interest, we know the total amount already right from the beginning, depending on the period that you want to deposit or you want to borrow, the number of periods you want to deposit or you want to borrow. But for compound interest, sometimes you lost track of how fast it will grow and ended up owing a lot of money to the bank or to the lender.